Have you ever wondered where all your Instagram photos, YouTube videos, or Google searches are actually stored? When people talk about the cloud, they often imagine something abstract and intangible, but in reality, all the data lives in very physical locations, buildings filled with servers located across cities like Mumbai, Hyderabad, or Noida. To visualize this, imagine walking into a high security warehouse, but instead of shelves stacked with goods, you see endless rows of blinking machines humming quietly in a controlled environment. This is a data center, the physical backbone of the internet. It's the place that ensures all digital activities function smoothly, whether that's watching a movie, making a UPI payment, or uploading a video. Think of a data center as a giant library, but instead of storing books, it stores data. Everything from emails and selfies to banking transactions and YouTube scripts. And unlike your local library that shuts its door at night, this facility operates 24/7, 365 days a year. So the next time you are binge watching Netflix late at night, remember that those videos are not floating in the air. They are being streamed from physical servers inside a building, possibly situated in a data center not too far from where you live. Like any large factory or utility, a data center requires multiple inputs to operate efficiently. It needs continuous power, high-speed connectivity, state-of-the-art cooling systems to prevent overheating, and multiple layers of physical and cyber security. These are complex facilities, quietly ensuring the uninterrupted flow of digital services we now take for granted. In simple terms, a data center is where the internet lives. Without these facilities, there would be no cloud computing, no streaming platforms, no artificial intelligence, and certainly no real-time financial services. They form the beating heart of the digital economy, and their role is only expanding with each passing year. Just as real estate comes in all shapes and sizes, so do data centers. From massive hyperscale setups to compact edge facilities, each type serves a unique purpose in the broader digital ecosystem. Understanding the different types of data centers helps investors evaluate where the value is being created and which business models are better suited for scale, speed, or control. Hyperscale data centers are the giants. Built and operated by tech majors like Amazon Web Services, Microsoft Azure, and Google Cloud, hyperscale data centers span millions of square feet and house thousands, sometimes millions of servers. These facilities form the backbone of everything from cloud storage to real-time analytics and media streaming. What sets them apart is their ability to scale rapidly. Imagine millions of users logging in to watch a live sports final like, say, IPL final, or to use AI tools during peak hours. Hyperscale data centers are designed to handle this surge effortlessly. They expand computing power as needed, just like a supermarket adding more billing counters during rush hour. In a world where digital demand is accelerating, hyperscale centers offer the scale and resilience required to meet the demand. They are not just participants in the internet economy, they are its foundation. Colocation centers serve businesses that cannot or do not want to build their own data infrastructure. These centers offer shared space where companies install their own servers while relying on the facility for power, cooling, and connectivity. Operators like Control-S, STT-GDC India, and Equinix specialize in co-location services. These setups allow companies to focus on their core digital services without investing in high-cost infrastructure. This model is especially important for startups, fintech firms, and mid-sized enterprises that want flexibility without compromising on performance or security. The third type are the edge data centers. Edge data centers are smaller facilities located closer to the end users. Their role is to minimize latency or the delay between sending and receiving data. They are essential for services that require real-time performance. Think of them like Zomato kitchen hubs that operate in specific neighborhoods to deliver food faster. Similarly, edge centers reduce the time it takes for data to travel, enabling seamless experiences in gaming, navigation, and augmented reality. As 5G networks expand and real-time applications grow, edge centers will become more crucial in supporting low latency, high performance use cases. Finally, we come to what are known as captive or enterprise data centers. Some companies, especially in sectors like banking, telecom, and insurance, prefer to build and operate their own data centers. These are referred to as captive or enterprise centers. The primary reasons are control and security. Companies that handle sensitive customer data or have stringent regulatory obligations often prefer to maintain their own infrastructure. While capital intensive, these centers offer companies complete control over uptime, performance, and data protection. So, to recap, there are four primary types of data centers. Hyperscale centers are vast and global, built to support large scale digital ecosystems. Colocation centers are shared facilities that offer affordable, scalable solutions for growing businesses. Edge centers are small, fast, and placed strategically to reduce latency. And finally, captive centers are privately owned and operated for maximum control and security. Each of these plays a distinct but complementary role in today's digital world. Together, they form the hidden infrastructure that powers cloud computing, artificial intelligence, e-commerce, fintech, media, and more. If you have been with me so far, you may be interested in our flagship course on one of the sunrise sectors, which is semiconductors. When some of us hear the word semiconductors, we think too technical, not for me. But smart investors know this. Semiconductors are the new oil. From smartphones to AI, EVs to defense, cloud computing to modern healthcare, chips power everything today. Global investors who spotted this early made serious wealth from companies like Nvidia, TSMC, MediaTek, Qualcomm, SK Hynix, Samsung, and Applied Materials. These are big names now and have turned into multi-baggers over the last decade or so. Now here is the exciting part. India is entering this game right now. Government has a massive outlay of 10 billion US dollars for Semicon India program. That's easily the highest incentive announced for any sector here in India. Big players like the Tatas, Adanis, Vedanta, HCL, and some smaller ones too like CG Power, Keynes, Dixon are all eyeing this opportunity. They are setting up chip manufacturing, packaging, and design hubs. So we spent nearly 2 months researching and breaking down this complex industry and then built this course that explains it all simply and clearly from an investor's angle. You learn how the chip manufacturing, packaging, and design industry works, where India fits in, which Indian and global stocks are worth tracking, and how to avoid the hype, manage the risks, and spot the real opportunity in this sector. Check the link to our course on semiconductors in the description or in the pinned comment below. Thank you. As the digital economy grows, so does the need for robust, resilient, and distributed data infrastructure. And with India emerging as a key player in this global shift, understanding the structure and function of data centers is no longer optional for investors. It is essential. This is not just a technology story, it's a long-term infrastructure investment story, quietly compounding in the background but ready to define the next decade of digital growth. Now let's talk business. We have covered what data centers are and why they matter. But here is the practical question most investors are really curious about. How do data centers actually make money? This is more of a financial question than a technical one. Whether you are an early stage startup founder, a retail investor, or someone trying to understand the future of digital infrastructure, getting clarity on the revenue model can help you separate long-term value from temporary hype. So let's break it down step by step. The most fundamental and consistent income stream for a data center is rental revenue. You can think of this as a digital version of commercial real estate. But instead of renting office space to people, data centers rent server space to companies. This approach is referred to as colocation. Here is how it works. A business owns its servers and IT hardware but doesn't want the cost or operational hassle of setting up an entire facility. It's too capital intensive and too complex. So instead, the business approaches a data center operator with a simple request. Can we host our servers at your location? The data center agrees and offers them the following: a dedicated physical space for their servers, continuous electricity supply, robust cooling infrastructure, around the clock uptime, physical and cybersecurity monitoring, and access control. In essence, it's like renting a high secure, always on apartment with full maintenance and power backup. But instead of housing people, it houses critical computing infrastructure. From a revenue standpoint, the client pays a monthly fee. This fee is collected based on several factors, including the number of server racks used, the square footage occupied, the committed level of power usage, and any additional features like isolation zones or enhanced security requirements. What makes this model especially attractive is its predictability. These contracts typically run for multiple years. Payments are made monthly and services are rarely cancelled midway. The result is a recurring revenue stream that forms the cash flow backbone of most colocation businesses. For investors, rental income represents the foundational layer of financial stability in the data center business. It is reliable, it's contractually secured, and it provides strong visibility into future earnings. Operators often use this revenue as a base to justify expansion plans or manage long-term debt obligations. It may not sound glamorous, but it's rock solid and predictable. Next, we move on to another critical but often misunderstood source of revenue: electricity charges. Data centers consume massive amounts of power, and they don't just bill clients for exactly what the utility company charges them. There's a margin built in, a concept referred to as a power uplift or power rate markup. Here's the logic behind it. Supplying electricity in a data center is not as simple as running a wire to a wall outlet. Operators must invest in and maintain robust electrical infrastructure. This includes installing power distribution units, setting up backup systems such as diesel generators and uninterruptible power supplies like the UPS, and ensuring seamless switchover during outages, and managing energy intensive cooling systems. In fact, in many data centers, cooling alone consumes as much electricity as the computing equipment. These systems ensure uptime and resilience, but they are expensive to build and maintain. To cover these costs and earn a profit, data centers mark up the electricity rate when charging clients. Depending on the level of redundancy, the energy source, and the tier of service provided, this markup can range anywhere from 5% to 30%, sometimes even higher. For premium facilities, those offering green energy options or tier 4 level uptime, clients are often willing to pay even more. The reasoning is simple. The cost of downtime is far higher than the premium they pay for reliable energy. You may be surprised to note that this revenue stream is not insignificant. In many co-location businesses, electricity related charges can contribute between 30% to 50% of total revenue. Electricity charges are not just a cost pass-through, they are a critical profit center. While hyperscale clients like AWS or Google may negotiate cost-based power rates due to their volume, mid-size enterprise customers often pay marked up rates. This adds significantly to the operator's profitability, especially when client usage is high. Another key area where data centers generate revenue, often quietly but very profitably, is through connectivity services. Let's consider the situation. A client has rented space and installed servers, but the setup isn't functional until those servers are connected, not just to the internet but often to other clients and cloud providers. In other words, the servers are physically in place but digitally offline. To make everything work, several network services are needed. First, the client must secure internet bandwidth. This is the core connection to the outside world, allowing data to flow in and out. Then come cross connects. These are dedicated low latency private lines that connect the client servers to other businesses operating within the same facility or another facility. This is especially useful in industries like finance, where milliseconds matter when connecting to payment gateway or to the stock exchange, etc. And finally, there are cloud on-ramps, direct fiber optic links to cloud providers like AWS, Microsoft, Azure, or Google Cloud. These ensure ultra-fast, secure access to hyperscale infrastructure. Each of these connectivity services is billed separately. Charges may be based on bandwidth consumed, the number of ports used, or the distance data must travel, and all of them carry attractive margins. So, from an investor angle, connectivity services may not appear significant in the top line, but they are highly profitable and extremely sticky. Once established, clients rarely change their networking configurations. That's because the technical risk and business disruption is too great. So, from an investor's lens, these services are quite compounders, recurring, high margin, and integral to customer retention. Now, let's explore a more sophisticated layer of monetization: managed services. This is where data center moves beyond being a landlord and becomes a full service operator. Some clients, especially mid-sized enterprises, prefer not to manage their own IT infrastructure. They want a solution where they don't have to worry about hardware procurement, software updates, or system monitoring. In such cases, the data center offers an end-to-end managed package. This kind of service is like opting for a fully managed hotel stay instead of renting an empty room and setting everything up yourself. The data center takes care of everything from the hardware to the upkeep. For starters, the client doesn't need to bring their own servers or storage systems. The data center provides all the essential equipment as part of the package. On top of that, they handle regular maintenance too, including critical security patches and firmware updates so things stay secure and up to date without client lifting a finger. There's also continuous monitoring and performance tuning to keep things running smoothly, along with regular data backups to prevent any loss. And in some cases, they even help manage the client software, especially if it is a critical application that needs special attention. In short, it's a hands-off, worry-free solution where the client simply focuses on their core business while the data center ensures everything behind the scenes just works. Think of it like renting a furnished apartment where everything is taken care of, from housekeeping to internet setup. You pay more, but you also offload all responsibility. Managed services command premium pricing. They carry higher margins because what's being sold is not space or power, but expertise. And once clients onboard, switching becomes difficult. The provider becomes deeply embedded in the client's IT operations. From a financial standpoint, managed services introduce a higher value revenue layer. This is especially important in markets where data centers are commoditized. Expertise, reliability, and customer trust can become differentiators and profit drivers. This part of the business adds resilience and margin depth. Finally, we turn to the model that defines hyperscalers like AWS, Azure, and Google Cloud: cloud consumption. This model is fundamentally different. Rather than renting racks or buying servers, clients simply request computing power as and when they need it, and they only pay for what they use. Let's take a real-world example. A fintech company may request virtual machines for backend processing, a few terabytes of cloud storage for user data, and maybe several GPUs to run an AI model. The cloud provider allocates those resources immediately, and the client is billed based on usage, often down to the second. When clients pay for cloud services, they are essentially paying for a few key things. First, there is storage. This could be basic object storage like Amazon S3 or more complex structured storage like managed databases. Then comes compute power, which means using virtual machines that run on CPUs or GPUs depending on the workload. They also pay for networking, which includes things like moving data across regions, setting up virtual firewalls, or securing access between different cloud environments. More recently, many clients are also paying for AI tools, whether it's training large models, running inference engines, or simply hosting pre-trained AI solutions. And finally, there are application-level APIs, tools that let developers plug in features like image recognition, speech-to-text, or even language translation into their own apps. So in short, cloud bills typically cover storage, compute, networking, AI capabilities, and ready to use software components, all delivered as scalable services. This model is powerful because it is elastic. It scales automatically with demand. As the world builds more digital apps, trains more machine learning models, and processes more transaction in real time, cloud consumption grows and the revenue grows with it. So if co-location is like renting a hotel room, cloud consumption is like paying for utilities, electricity, gas, and water based on actual usage. It transforms infrastructure into a metered service where scale is limited only by customer demand. And that's why cloud providers have achieved margins and growth rates that traditional data centers can only admire. So, to summarize, how do data centers actually make money? Well, they rent out physical space, they charge for the power you use, often with a margin added on top. They make money by providing essential network connectivity. They also offer value added managed services, which comes at a premium. And if it is a hyperscale provider, they bill you based on how much you actually use, like pay as you go. Each of these streams supports a different kind of customer, from enterprises looking to outsource IT, to startups scaling fast, to massive cloud platforms serving billions of users. So, to sum it all up, the more a business relies on digital tools, automation, AI, and cloud infrastructure, the more value it derives from data centers. And the more services a data center provides, the more money it makes per customer. If you are analyzing data center operators, whether it's a hyperscaler like AWS or a domestic colocation player, look closely at the revenue mix. That's where the edge is. That's where margins are created. And that's what separates infrastructure from innovation.